Thank you much for the invitation and for the organization of all this amazing meeting. And if you are not from Spain, we are not in the lunchtime, okay? There's another 3 talks. So I think one of the major questions here is, what is megafauna, right? So 2 talks, 2 different definitions. So for any normal people, we think that megafauna is big animals. It can be from dinosaurs, whales, big fish, mammoth. When we look at the distribution of body mass of mammals, this is terrestrial megafauna, this is aquatic or marine megafauna. And the difference here is this line is that the species that were extinct, right? And here you can see that there wasn't major extinction of large mammals in marine environments. So there was basically a few definitions for terrestrial megafauna. One is mammals above 45 kilograms. That's 44 point something, right? But basically 100 pounds. It was made by Paul Martin. And then Norman Owen Smith proposed a mega herbivore for more than 1,000 kilograms. And following the same line, we propose for larger herbivores 1,000 kilograms and 100 kilograms for carnivores. But at the same time, Dennis Hansen and I published a few years ago another definition. So I think the whole conference is to discuss about what is a megafauna. When we use the threshold of 45 or 1,000 kilograms, if we use 45 kilograms, we are getting about 9% of all species living or extinct. Well, extinct from the Pleistocene to here, right? And if we use 1,000 kilograms, it will be less than 1%. So we basically have to choose. But why do we have this threshold? Why is 100 pounds? Well, one is clear. It's Imperial metric. So British and Americans use it, Imperial metrics, and they said, well, 100 pounds. Okay. But there's no clear ecological reason for 100 pounds. Nothing different for 100 pounds for 200 pounds or 150 pounds. And it's funny that even today, people who work in gymnastics publish this year using 100 pounds or 45 kilograms, even for marine megafauna, that they are bigger than terrestrial megafauna. If you use mammals bigger than 1 ton, or mammals that are not controlled by predation, if you look at the data set on predation for, this Africa data set for Kruger and Serengeti, so this Sinclair paper in Nature, lions preys up to 500 kilograms. So we could say, okay, anything bigger than 500 kilograms, a megafauna. But if you use the data from Norman, it's a bit bigger, 650 kilograms of body mass of the prey. But then, what I did is just a rough data. I got the paper from Gilbert, who has the age of the elephants killed by the lions. So I transformed the age into body mass, and you will see that elephants in the middle body mass are more killed by lions than small ones and large ones. Although predation attempts are higher for adults. Okay, so they try to kill the big guys, but they cannot prey on them. And these small ones, they don't prey because the females or the group protect them. So the solitary males between 500 kilograms and a bit bigger than 1 ton are killed. So they are controlled by predation. So what are the alternatives? Can we have other alternatives for this debate of 100, 1,000? So a few years ago, with Dennis, we were drinking coffee in Stanford and say, well, there's a lot of species big enough that are not considered megafauna. And some are really big, like giant tortoise. Others are big for a bird. So a dodo, the last estimation is about 15 kilograms for a pigeon, right? A dodo is nothing more than a pigeon. And if you look for lizards, they're the Canarian lizard, 500 grams. They are huge lizards for that particular ecosystem. So a lot of attention on megafauna studies have been given or focused on mammals. So we know that here is some groups of mammals all over the world, and in black are the ones who were extinct by the end of the Pleistocene. So clearly there's a trend for all the big guys to disappear. So, and Jens proposed this, we published this this year. What's the distribution of these large mammals if there were no humans? So you could see here that South America has the highest diversity of mega herbivores, and this is the distribution with humans, right? So we reduce the distribution, leave only megafauna in Southeast Asia and Africa. But what about other large vertebrates? The same is happening with giant tortoise, with other lizards. So this is a paper with Dennis Jensen, and there was giant tortoise all over the world. We always think about Galapagos or Aldabra, but they were giant tortoise all over the world. The same for large birds. We are trying to compile more data on that, but huge birds, they still are in Brazil. The distribution of ostrich reduced a lot. Madagascar, we lost the elephant birds, we lost all the moas, etc., Genyornis, etc., etc., etc. So for me, what's a clear signature of the Anthropocene is what we are calling the downsizing effect. And what is this downsizing effect? Okay, imagine that we go back 12,000 years ago to South America. This was our landscape in the Pantanal of Brazil, where we have all these giant sloth, the saber-toothed tiger, horse, Macrauchenia. You have some proboscideans here, giant armadillos. There was a land of giants, high diversity, lots of animals bigger than 1 ton. So if you look at the distribution of body mass of a single community, we arrive from 7,000 kilograms to, let's say, 5 kilograms for a mammal community. And this is what is today. So in the universities, in the high school, or even the academia, we simply forget that all these big guys, they were present in our communities that we study until very recently. And one idea that we are proposing, that's not only the large species, but the largest individuals are the ones targeted by hunting. So if you have a large community here, a complete community, humans start harvesting the largest individuals of the largest species. This will cause selection for smaller body mass, increasing mortality, fecundity, increasing predation risk because the animals are getting smaller, right? There's loss of genetic diversity. If this happens in the entire distribution of the species, you get a local extinction. So humans move to the second largest. This happened very quickly, right? And shift to the next one, until you get a downsized community. So we all know that humans like to hunt the largest individuals of the largest species. This is happening today, and it's probably happened in the past. And when we look at the what we are calling this downsizing effect, let's say that we get the biggest herbivores in South America. This was the toxodont, used to weigh 7.5 thousand kilograms. They gone. Humans hunt them. So we move down, 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 up to the largest living mammal. That's the tapir with 250 kilograms. Okay? So we have a downsizing here in 30 times for the same ecological process, 2 herbivores. Tapirs are threatened by extinction. I'm not sure if my grandkid will see a tapir in the wild because of poaching, fragmentation. So let's go down to the list of IUCN up to the first species that are not threatened. It's the howler monkey with only 10 kilograms. Okay? So it's least concern. If we look at the body mass magnitude of decline, was more than 750 times for herbivores. Okay? The same ecological function. Is it big? How big is that? 700 times. Well, let's see what we can compare. It's like to ask this tiny mouse to play like LeBron James. Exactly the same thing. It's impossible. So a howler monkey will never play the same ecological rule of a mastodon or even a tapir. And it's happening in the past, but very much less. If you get the largest dinosaurs, the largest mammals, the declining body mass was only 4 times, right? So we are having a tremendous effect in the magnitude of the fauna that we are living on the planet. So a few years ago with Rodolfo, we published this on the distribution of body mass for the extinct mammals in the Pleistocene. The body mass, the distribution of body mass of mammals that we are sure were extinct by humans in the Anthropocene. This you can say, oh, but some were because of climate. We'll stay here for many, many days debating that, but it's more likely that humans kill most of these guys. And if you look at the IUCN red list and plot the body mass of all the threatened species, that's the distribution that you get. Can you see the pattern here? This is a median. Okay, let's plot now the distribution of species that are not threatened at all. That's the distribution. So this is going to be the final distribution of body mass of mammals in the Anthropocene. Unless you are a domesticated animal or an invasive species, you won't get more than 100 kilograms. But we know that these big guys, they play a tremendous impact in the ecosystem, can be in marine ecosystem or in aquatic ecosystem. And I've been working a lot on a particular trajectory here, an ecological process that is seed dispersal. And 10 years ago, with Pedro and Paulo Guimarães, we published a paper in PLOS One, trying to see what's the impact of these large animals on seed dispersal. And we were particularly interested in how these large guys shape fruits from trees. So just a major figure of the paper is that when we look at the individual seed mass in a fruit and number of seeds per fruit, all these points here are non-megafauna fruits. So you increase the number of seeds, but these seeds cannot grow, cannot be much bigger in non-megafauna fruits. But for all the megafauna fruits, they can. So it seems that because these guys are so big, these particular plants, they can have bigger seeds than you would expect by the number of seeds per fruit. So there's a cacao, there's a tomato. So another point that we are studying right now is another key ecological service provided by terrestrial megafauna, that's long-distance dispersal. So these guys eat a lot of large fruits, but they take these seeds to very, very far distance. They promote gene flow. So with Pedro, Matias Pires, and Paulo Guimarães, we are trying to estimate first how much food these guys could eat. What's the distance they move? And where they move, right? So we are using basically some estimation for the extant megafauna and plot against the body mass of extinct species, and then run some simulations of Levy walk or random walk. You choose. We try several models, and we can compare here with these 3 living megafauna with 2 extinct megafauna. So it's clearly that these big guys, they could take seeds up to 5 or 10 times far away than the small frugivores, right? So they are important eating fruits that nobody eats. They take the seeds farther than nobody takes. And what are the consequences for that? Well, one is gene flow. And gene flow will affect the genetic diversity of the plants. So, as I said, all these are in progress. We are analyzing these with several species, and we notice that the structure of megafauna fruits are different from non-megafauna fruits, like dispersed by birds or by wind. And actually, Pedro and Nestor, Alfredo already found what we thought for the megafauna for the lizards, the one that's really megafauna for Canary Islands. So in Canary Islands, you have these large lizards who went extinct, and this is the distribution of the dispersal kernel. And they found exactly the same. There's a truncation in the dispersal distance when you remove the large frugivores. In this case, the largest lizards. So to take home messages of this, I put more questions than really take home messages. So megafauna is really poorly defined. So every talk here will give a different definition. So thanks for organizing all these, and so we can get to a conclusion. Usually does not include fish, but I'm happy to see your talk and your talk. Birds, reptiles, and invertebrates, we never say that they are megafauna. What's make a megafauna different? That's another key point. What differ big organisms from other? It's about the scale that they affect the ecosystem. What are the consequences of losing the largest species and the largest individuals? You forget about the largest individuals in the population. And what are the ecological processes that are unique to large species? What's only elephants do? What's only whales do? Or this big lizard in Canary Island? So I want to thank my group of friends. Some are well beyond the megafauna definition. Others are struggling to get there. So I've been really happy to work with so many people. And thank you for your attention.